There's one problem that all the generic anti-inflammatory diet programs out there have in common, and it's that our inflammatory food triggers in our diets are predetermined by our genes and DNA. Because our genes and DNA are all different, our inflammatory food profiles will all be different. These anti-inflammatory programs are based off generic nutritional ideas that this food may be good for you for a specific reason, or this food may be bad for you for a specific reason. But our genes and DNA don't subscribe to those general nutritional ideas. An example might be this food is good because it's high in antioxidants and high in bioflavonoids, so it's going to be anti-inflammatory for everybody. Or this food may be bad for you because it's high in bad fats and lectins, which can cause inflammation. Now, there may be examples where those aspects are true for some people, but quite often some of those foods that are recommended as anti-inflammatory can be inflammatory, and some of those foods that are recommended as being inflammatory can actually be healthy for us. A simple example of this would be, think of the food guides in North America. We're told to eat multiple servings daily of healthy grains, nuts and seeds, fruits and vegetables, good proteins, and so forth. Well, if a celiac patient subscribes to that generic ideal and they eat multiple servings of healthy grains every day, they're likely going to be very sick. If a person with a peanut allergy goes and eats nuts and seeds every day based off that guide, they're going to be quite sick as well. Someone with a dairy allergy, if they go and eat yogurt with calcium and probiotics in it, but they're allergic to the protein in the yogurt, they're going to be quite sick as well. So this happens all the time. People come into clinic and they say, I eat a very healthy diet. Why do I have so many inflammatory issues and other health issues? And the answer can be quite simple. What you're perceiving as being healthy for you likely isn't healthy for you. You're eating a food with good intentions, but your immune system doesn't agree with that. Our immune system and our genes and DNA don't often subscribe to these generic nutritional ideas that we read about on the internet. Each person's ideal anti-inflammatory diet protocol is unique to them and them alone. And that's what we have to figure out. And that's what we're going to talk about in this video. So in this video, we're going to talk about how our genes and DNA actually dictate what our immune systems react to from a dietary point of view. It's not that hard to explain. We're also going to talk about the three main reasons why people have so much difficulty figuring out these inflammatory food triggers. And finally, we're going to come up with a bit of a roadmap or a plan so people can start to put this inflammatory food puzzle together and start to feel better. So let's get started. Now, before we get into that, we need to talk about inflammation a little bit. Most people tend to think of inflammation in terms of muscle and joint inflammation, but inflammation is often much broader in us than most of us think. Think of chronic skin disorders, eczema and psoriasis. This is an immune reaction, an inflammatory reaction against a tissue in the skin. And when people have those conditions, it's not just for a day or two often, it's often for months, if not years and years on end. Think of people with asthma. They can have this from childhood right through to adulthood. That's a chronic inflammatory issue in the respiratory tract. Sinus congestion, the same thing. Recurrent yeast and bladder infections, kidney infections. People can have those over and over and over again for months, if not years on end. That's an inflammation in the urinary tract. This can affect our organs and glands. Think of gallbladder issues, cholecystitis or cholelithiasis, gallstones in the gallbladder. It can affect our liver. Think of non-alcoholic fatty liver disease or chronic inflammation in the liver. It can affect our thyroid gland. It can affect the pancreas. It can affect any other organ in the body. Another really good example here is think of gastritis, reflux, indigestion, and heartburn. Gastritis is Latin for stomach inflammation. And when people have that condition, they don't have it for a day or two often. Quite often they have it chronically and they need to medicate it. And this can go on for decades. So think of inflammation as more than just muscle and joint. Some people may say, I don't have muscle and joint issues, so I don't have inflammation, but yet I'm taking reflux medication. I take a puffer for asthma and I have a steroid cream for my skin. Well, those are inflammatory problems. Another way you can think of this is if you can take an anti-inflammatory medication for a problem, and if it helps, it confirms that that problem is inflammatory. Steroid creams for eczema and psoriasis. Steroid creams are cortisone creams. Cortisone is an anti-inflammatory. So if you put that on your skin and if it helps, that's an inflammatory problem. Puffers for asthma, either steroid-based or leukotriene inhibitors, they're both anti-inflammatory. So if you use a puffer for asthma, if it helps, it's an inflammatory problem. Decongestion for sinus congestion, they're anti-inflammatory. And we already talked about some of the medications used for reflux, indigestion, and heartburn. One of their mechanisms of action is actually as an antihistamine, which is an anti-inflammatory. You can see inflammation can be much broader in our bodies than we think it is, and much more chronic. And this chronic component is actually very important because if our immune systems are reacting to something over and over and over again, day after day, that puts an enormous strain on the immune system, which is supposed to be there to fight bugs and bacteria and viruses. So it can make us susceptible to these types of immunological issues. But it also puts a metabolic strain on the systems that support the immune system, predominantly the adrenal glands. This can lead to sort of metabolic burnout states with issues with chronic fatigue and mood and anxiety disorders and these sorts of things. We talk about this specifically in a video called Chronic Inflammation and Chronic Fatigue. There'll be a link in the description below for that video. If any of you have any of these chronic inflammatory issues, I'd encourage you to watch that video as well. So the critical question is, what is causing the inflammation? Now, quite often inflammation gets blamed on psychological stress. Once we see our health practitioners, we have blood tests done, we have x-rays, we have all the scopes and scans done, and there's no other obvious reason for the inflammation. Stress tends to be a bit of a catch-all explanation for that. Now, I'm not suggesting stress can't have a serious and adverse impact on our health, but stress actually can't cause inflammation. Stress can make an inflammation worse. It can fan the fire, it can feed the fire, but it can't actually light the fire. One of the primary components of the immune system which initiate most inflammation would be the white blood cells. There's far too many types of white blood cells and far too many processes that they go through to get into in this video. So we'll just classify them all as white blood cells. They are a mechanically driven system, meaning they function through a lock and key mechanism. The white blood cells have receptors on them. They're like little arms with feelers on the surface. These things reach out into the tissues and they bounce into things, and they determine what's allowed and not allowed in your body by how they feel. When they come in contact with something that's foreign to the body, they'll grab onto it and they can initiate a whole series of events which can lead down the pathway to inflammation. Antibody production, cytokine production, activation of other white blood cells. There's many different processes that can lead to the inflammation. But the main point here is the receptor actually has to physically bind to an antigen or an allergen to initiate this inflammatory mechanism. We'll go back to the lock and key mechanism. The lock would be the receptor. The key would be the antigen. You cannot open up a door unless you have the right key to fit into that lock, and if the key will turn the lock. So the white blood cells reactions leading to inflammation require the same activation of this receptor to initiate the inflammation. So to suggest that stress could actually trigger the inflammation, you're suggesting that this white blood cell receptor could actually bind to a stressful thought in your head. And is that possible? It's not. The receptors actually have to physically bind to another substrate to initiate this cascade. Now, again, stress can affect inflammation, and we talk about this in the fatigue and chronic inflammation video. We're going to talk about it shortly as well. So understand the genes and DNA component to our food allergy profiles. We have to talk about proteins and a little bit about their structure and how they're put together. Proteins are made of amino acids. There are 22 amino acids found in nature. So imagine a protein molecule is a big long string, and we put little colored beads on the string, and we have 22 different colored beads in a bucket that we can put on that string. Now, and those beads are really tiny and the string's 100 feet long. How many different combinations and sequences of colors can we make on that string with 22 different colored beads? It's literally infinite. So these strings of beads then get crumpled up into these three-dimensional blobs. How many different shapes can we take those strings of beads and put them in? It's literally infinite. Now, genes and DNA determine the coding of these amino acids on the string. It's the computer code that tells your body what bead to put on the string next. You get that code from your mom and your dad and your grandparents. That's why the proteins in your body look like your family upline. Hair color, skin color, eye color. The proteins on the inside of our body and then on the white blood cells look like our parents and grandparents as well. We just don't see those proteins. There's literally an infinite times infinite times infinite number of sequences of colored beads on the string and shapes that the strings can be put into. This explains the incredible diversity out there in nature amongst all living things because of this incredible variation of the amino acids sequencing and structure of the proteins. Now, this is a more accurate representation of these receptors in the white blood cell. These little blue structures right here going in through the cell wall, these would be the receptors in this cell wall. They go right through the cell wall, and basically you can see the complex three-dimensional shape and structure of these receptors. And again, you can see based off the sequencing and the arrangements of the amino acids in the strings, how variable this structure can be. Now, the antigenic or allergenic proteins could be represented by these red structures or these yellow structures. What happens is we have to have a protein which will mirror the face of these blue receptor protein molecules. Now, in celiac disease, one of these blue receptors here would mirror what gliadin looks like from a gluten protein point of view. Someone with a peanut allergy, this receptor would mirror the structure of a peanut protein. Same thing with a shellfish protein. So the genes and DNA determine the three-dimensional structure of these receptor proteins right here. And you can see that will dictate what our immune systems are going to react to from a protein or an antigenic or allergenic point of view. This is how our inflammatory food profiles are based off this genetic coding of the receptors and what proteins they're mirrored by. And our genes and DNA determine this, not based off generic guide ideals off an anti-inflammatory program off the internet. It's done through your coding and your genes and DNA from your family upline. We also know that some of these allergy profiles tend to run through families. We know celiac can run down through families. We know anaphylaxis can run down through families. So if peanuts or gliadin can have a genetic component to it with people with anaphylaxis or with celiac disease, why couldn't other people have genetic issues with other proteins from other foods? This makes sense, and this is what the basis of this video is going to be. So why are these issues so hard to figure out? There's three main issues that we're going to talk about here. One is people tend to focus on the wrong component of the food when they have a reaction after eating a food. The second is the timing of the reaction. We tend to think that if we eat a food today, the reaction will happen right after we eat the food. Well, there's another type of food reaction which can happen days to a week or two after we eat the food. And the third reason is we tend to think, what food am I allergic or reactive to? We have to think, what food or foods are we reactive to? Most of us have more than one food triggering inflammation in our body. Imagine trying to unlock a wall safe with only one number of a three-number combination. You won't be able to open up that door and fix the inflammation unless we identify all the inflammatory triggers in the diet and line them up at the same time. So the component of the food from an inflammatory trigger point of view is protein. We cannot have a sugar allergy. I know this is a little controversial, and we're going to explain it more as we go, but proteins are the primary culprits here. If we think of celiac disease, the inflammatory protein there is gliadin. It's not the starch in the wheat, it's not the flour in the wheat or anything else, it's the protein in the wheat. If we think of someone with a shellfish allergy, for example, like a scallop, well, how much fat or sugar would be in that scallop? It's actually to the protein in the scallop. The same thing with a peanut. Now, the proteins are made of amino acids. This is a diagram indicating the structure of an amino acid. It's an amino group, which is a nitrogen-containing compound, attached to a carboxyl group or an acid group. This is where you get amino acid. It's this nitrogen component that is the protein-based component of the food allergen. This is a critical concept when we're talking about sugar. Now, sugar, pure sugar, an example would be glucose, would be C6H12O6. If a white blood cell, the receptor here, if it could bind to and react against carbon, hydrogen, and oxygen in long chains, theoretically, you could have a glucose allergy. Well, glucose is what your brain burns for fuel. If you could have a glucose allergy, you would die instantly. Theoretically, you could have an H2O allergy, a CO2 allergy, or an O2 allergy. That is the air and water. Can you have an allergy to air or water and still live? No. Now, we can have other bad reactions to fats and sugars, don't get me wrong. We'll talk about those shortly. But your white blood cells can't react to it allergically. They need to bind to another protein. So again, I'm not saying eat more sugar and you're going to feel better. Nothing bad has ever happened by cutting back refined sugar in your diet. It's a healthy thing to do. But from an inflammation point of view, it'll have limited effects. We can eat too much sugar and get heavy, and that's bad, but that's a calorie problem, not an allergy problem. We can have highs and lows in our sugar like a diabetic, and that can kill us, and that's bad, but that's a diabetes problem. It's not an allergy problem. We can be unable to digest fat or sugar like lactose intolerance and have cramps, gas, and diarrhea from it, and that's bad, but that's a food intolerance. That's not a food allergy. What happens there, we eat or drink lactose. We don't have enough of an enzyme in our small intestine to chop it up and absorb it. So that big load of sugar goes to the colon undigested. The colon's a trash compactor filled with yeast and bacteria. And what does yeast do to sugar in a warm, wet environment? It ferments. So the bowel fills up with gas and fluid, and we have cramps, gas, and diarrhea. Now, that whole process from the mouth to the rectum, I never said the word immune system or inflammation once. We ate a food here, it didn't get absorbed in the here. It went down to the bowel and fermented, and you pooped out the fluid. There was no inflammation in that process. Sugar can divert our cortisol away from inflammation. We're going to talk about that more shortly here. So the focus on the food needs to be on the protein. What happens here, someone would eat a sugar cookie and they'll feel inflammation after, and they tend to blame it on the sugar in the sugar cookie. But they forget that that sugar cookie also had wheat in it. It also had butter in it. It also had eggs in it, which are all protein-based foods. Someone may eat a bowl of ice cream and have inflammation after, and they blame it on the sugar in the ice cream. But the ice cream is dairy protein. It may have had some fruits in it that you could have been reactive to as well. So we have to identify the component of the food that's causing the inflammation, not just look at what we think in the food is causing the inflammation. And the component of the food we have to look for is the protein. Why this component is so important. If we think of a person with a dairy issue, if I don't explain this protein component and the difference between food intolerance and food allergy, if I ask them to give up dairy products for me, most people automatically think of lactose. So they will go away and they might buy lactose-free dairy products, milk made from a cow but with the lactose removed from it. And if they have a milk allergy to the protein in the milk, the lactose-free stuff won't do them any good. They may have less diarrhea, but all their inflammatory stuff will stay the same because they're still eating the inflammatory protein found in that food product. So you can see how this protein component can actually confuse a lot of people with respect to their food reactions. Now back to the cortisol concept here. Cortisol is an anti-inflammatory. It's a form of adrenaline. It has many other jobs in the body. It's a stress-suppressing hormone. It helps us control our blood sugar with insulin and glucagon. It's an anti-inflammatory. It has other jobs as well. We're just going to focus on these three elements here. When we're young and healthy, we have lots of cortisol. We can deal with lots of stress. We can deal with lots of inflammation, and we can control our sugars really well. But as we get older and we go through andropause and menopause, our hormones fall. It's not just sex hormones that fall as we get older. All of our hormones fall and our cortisol levels fall as well. So we have less cortisol to do all these jobs. Now, if we have a little inflammation over here and we go through a really stressful time, this little volcano erupts over here, our cortisol has to come over here to deal with the stress. Think of it as fight or flight response. Well, it can start to steal cortisol from the inflammation. So what will happen is when you are psychologically stressed over here, your inflammation levels will rise. And because you're stressed at the same time, you're going to think the stress caused the inflammation, when in fact it didn't. It just pulled your anti-inflammatory systems away from the inflammation. Now people say, I know when I eat sugar, my inflammation gets worse. The sugar didn't cause the inflammation. It was either a protein that came with the sugar that caused the inflammation, or the sugar diverted your cortisol down here to deal with the sugar, and it pulled it away from your inflammation levels. So what happens here, we eat high sugar diets and our inflammation levels will rise. It's because our cortisol is being diverted away from the inflammation. So one more time, I'm not suggesting eat more sugar or sugar is healthy for you. What I'm saying is it's not the match that lights the fire in most cases. The second reason is the timing issue with respect to our food issues. Most people assume if we eat a food, we'll have the inflammatory reaction right after we eat the food. This is the case with an anaphylactic reaction. A kid eats a peanut, their throat swells up right away. If they don't get an epinephrine shot and if they don't die, their throat will come back down to normal within a few hours. So it comes on immediately, it goes away immediately. These are called immediate hypersensitivity reactions. They're the anaphylactic class. They'll tend to happen within minutes to hours of eating the food. The inflammation is triggered by a histamine release. Histamine causes redness, swelling, itching, and those sorts of things. That's why people take antihistamines for seasonal allergy type stuff. And it's associated with an antibody called immunoglobulin E or antibody E. Now, because these allergies come on so quickly, and if I ask people, do you think you have any of those types of allergies? Most often people say no. And then I say to them, well, there's a good chance you may have, and you just don't know about them. These allergies don't always just bother us on the back of the throat. Some people eat scallops, their throat is fine, but the inflammation affects their stomach and they vomit shortly after. Some people may eat strawberries and it can give them hives shortly after. Some people may eat a blueberry and it can give them diarrhea a few minutes after. Sometimes chocolate can trigger migraines. Histamine can trigger migraines. Histamine can cause constipation in the colon. Histamine can aggravate asthma. So quite often histamine can cause something as simple as chronic reflux indigestion and heartburn. So it's not just anaphylaxis in the back of the throat. Histamine issues can affect us systemically as well. But because we eat that food and we don't correlate that as an anaphylactic throat reaction, we don't think of us as having those reactions. So quite often this is a part of our puzzle. But usually with those reactions, they happen right after you eat the food. So it's a little bit easier to associate. There's a reason why sometimes they're hidden though, and we're going to talk about that next. The next type of reaction is called a delayed hypersensitivity reaction. These antibodies are called IgG and IgA. These are the same antibodies produced when someone gets a vaccine. So to talk about this for a minute, when you get a vaccine, you get this much vaccine, the size of the tip of a pen. 0.5 milliliter is a good standard vaccine dose. They inject it in your arm, your white blood cells go to it, they recognize it as being a foreign invader, so they grab it. They set up a photocopy shop with another cell called a B cell, and they start printing off antibodies. These antibodies are little clone soldiers that go back in the bloodstream and look to attack anything that looks like the vaccine. Now think of a tetanus shot. When you get that tetanus shot, you get this much. It'll produce a trillion-fold antibody response that can stay in your system for 8 to 10 years. A tiny little dose. A flu shot about a year. With COVID, we don't know yet. The point is a tiny little dose, trillion-fold response lasts a long, long time. One more thing of the vaccine, and this is the critical part. When you get the vaccine today, it's going to take 2 to 4 weeks for the antibodies to get produced. If you go on a trip somewhere and you have to have a shot before you go, you have to have the shot 2 to 4 weeks before you travel. With COVID vaccines, people weren't considered immune for 14 days after the second shot. The photocopy shop takes time. So why am I talking about that? Well, the same way you can react that way to a vaccine, you can react that way to a food. So to explain this, I'm going to draw this out in graph form. With an IgE reaction to a food, we eat the food, we have the reaction right away, and it tends to go away very, very quickly. So again, we can quite often figure those out. With a delayed reaction, we can eat a food a day, and the antibodies can take up to 2 to 4 weeks to reach their peak. And then if you never eat the food again, the antibodies will degrade very slowly over a long period of time. Now here's the problem. If you eat a food today and it bothers you next week and you don't figure that out, what might you do the next day? You might eat that food again. And the next day and the next day and the next day. Now every day you do that, these antibodies compound on top of each other. This can lead to a chronic overlapping compounding inflammation that you'll never correlate back to a food in your diet. You can eat a food today, it can bother you next week. I have psoriasis. I eat the food that I'm allergic to today, which is rice. My psoriasis flares up 5 to 7 days after I eat it every time. These delayed allergies, they compound and they're kind of persistent and chronic, the inflammation associated with them. These can cover up the histamine reactions we talked about earlier. You can eat a food today. You can have an IgE reaction to a food cause the exact same symptom that an IgG delayed reaction to a different food causes. And because this symptom never really goes away, you might be eating foods and having histamine reactions to it and not even noticing it. This isn't really, really important because in order to figure out these histamine issues, we have to get rid of the delayed allergies. People say, well, I had allergy testing done and it showed nothing. There's a reason for that. The IgE antibody is a very short half-life, meaning it's out of the system very, very quickly. So theoretically, a kid, and I've seen this in practice, a kid could eat a peanut at supper time, have a horrible reaction to it. They could have a blood test for a peanut tomorrow morning at 9 o'clock, and it may not show up because the antibody was eliminated that quickly. Now, if we can get rid of the delayed allergies first, and then you eat a food and have a reaction to it, it's going to be much more obvious to you. Think of it this way. If you eat a food tonight at supper time and you don't feel well, technically right now, you don't know if it's what you ate at supper tonight or what you ate last week sometime. If we get rid of these delayed ones right here, and then you react at supper time, we know as to what you just put in your mouth. So the order of figuring out these food issues is really, really important. And it's critical to understand and get rid of those delayed allergies before the immediate ones will start to present themselves more clearly. The other point to make here is these are considered food sensitivities. These are considered food allergies, but technically they are both allergies. The definition of an allergy is a white blood cell binding to an antigen producing an inflammatory response. That's what happens when someone eats a peanut. Their white blood cells produce IgE, release histamine, and the throat swells up. But an IgG antibody is produced by a white blood cell binding to an antigen. It's just producing the antibody in a different time frame. So these tend to get classified as sensitivities when technically they are true allergies. So another way to explain this IgA antibody is what's tested for patients with celiac disease. This A antibody is a delayed hypersensitivity reaction. And if someone has celiac disease, they get told they have a gluten allergy. But yet these reactions to other foods, they get told they are sensitivities. Technically, they are both allergies. It's just they affect us in different ways. I think the food allergies are assigned that term to imply some sense of urgency because anaphylaxis can kill you. And these delayed hypersensitivities don't cause the same type of anaphylactic reaction. But we can think of these types of allergies as actually being more dangerous because we can live our whole lives with these types of reactions and not even know about them. So the third reason why these issues are so hard to figure out, most of us think that we only have one food issue. But when I do testing, I see people with multiple food issues all the time. We seldom have just one inflammatory food reaction. The key to figuring this out is to identify them all at the same time and eliminate them all at the same time. The best way to explain this to you would be to show you some examples of some food sensitivity testing we did on actual patients with inflammatory conditions. That's what we're going to do next. Now, the test results you're going to see are what we call enzyme-linked immunosorbent assay tests, ELISA testing. This is a gold standard test procedure used in the hospital hundreds of times a day. They use this test to identify IgA antibodies to gliadin for celiac disease. They also do it for antibody titer testing. They do it for infectious disease testing for hepatitis, mono, and shingles. They do it for immunoglobulin assays. They do it for many, many, many different things. It's just they don't often do it for other foods aside from gliadin. That's what we're doing here. You go to a site called PubMed. This is the National Institute of Health's a public database for peer-reviewed journal research. You will find ELISA test procedures throughout that website on most of the studies being done from a research point of view. It's a gold standard way of identifying proteins in the blood. The reason I point all this out is quite often these food sensitivity tests for IgG and IgA reactions are considered not medically validated and not real tests. So to suggest that, you're actually saying that many of the tests used in the hospital today aren't medically validated, which we know isn't the case. These are true food sensitivity tests. Now, for full disclosure here, I have no financial or any other association with any food sensitivity testing company. I use multiple companies and I get no benefits from any of them outside of the test results for the patients. So let's look at some of these tests. And here's an example of a 31-year-old female. She presented with nausea and gastritis since childhood. She had a history of transfusions, and her anemia actually started before puberty. And when we saw her, her periods were basically 3 to 5 days. So again, we can't blame her anemia history on her periods. Before she came to see me, she went dairy-free for 2 months. She didn't see any impact on her symptoms, and she followed that up with 3 months of gluten-free. And again, she didn't see any change in her symptoms. That's when we met with her, we spoke with her, and she had actually gone ahead with the ELISA testing, as we mentioned earlier. And when you look at these test results, you're going to see 2 different colored lines for each food. There's a white and a dark colored line. The white lines are the IgA antibodies, the dark lines are the IgG antibodies. And they are both delayed hypersensitivity reactions. The A antibodies are actually the ones implicated in celiac disease. G antibodies typically aren't tested for celiac disease, and we'll talk more about that shortly. And when we look at her test results, her dairy grouping over here is extremely high. Normal would probably present over here somewhere. You can see her dairy proteins, casein and whey, which are really the only two that matter, are extremely high here. So she had a dairy issue. And remember, before she came to see me, she went dairy-free for 2 months, and she didn't see any impact, but yet she was allergic to dairy. She followed that up with a gluten-free diet. And if we look at her test results here, you can see gluten and gliadin here are basically normal levels. Now, one important point to make here, there are two proteins in wheat that we've tested for here. One is gluten, the other is gliadin. They are different wheat proteins, but the celiac testing tends to focus on gliadin, not on gluten. So she went dairy-free with no effect, even though she was allergic to dairy. She went gluten-free with no effect because she had put dairy back in her system and she wasn't reactive to gluten. Now, if we look at the rest for a test here, we see almond up here, soy, peanut and pecan, but egg was a big one and caffeine was a big one. And those were all a big part of her diet. So she followed this test up with a diet that eliminated dairy, egg, caffeine, soy, and almond. And literally within a week to a week and a half, her nausea and her gastritis significantly improved. And she had had that history since childhood, but she had been eating these foods since childhood. She noticed symptomatic improvement with her anemia in terms of shortness of breath and energy within about 4 weeks. That would take a little time for her iron stores to come back up. She saw improvements in her ferritin, which is her long-term iron storage. And when she's challenged those foods since, she'll see a relapse of symptoms. So she's basically avoided most of those foods since we tested her. And to make the point with the compound food issue that we talked about earlier, if we have 4 or 5 food issues and we give up one of them, you're trying to unlock that wall safe with only one number of a 4 or 5 number combination. We have to get the foods lined up at the same time to settle the immune system completely down sometimes in order to see improvements in the symptoms. We're going to show you several other examples of compound food pictures here shortly. Here's a test result of a 59-year-old male with severe psoriasis, reflux, and IBS. We're going to talk about some different types of anti-inflammatory diet protocols here. And this one specifically is the alkaline diet. This chap had done the alkaline diet and hadn't seen any improvements with it. Now, the alkaline diet, it's a diet low in animal fats and meats, high in fruits and vegetables, apples, bananas, berries, etc. And almonds are considered a very alkalinizing and low acid type of food. Now, let's look at his test here. No dairy issues, no beef or egg issues. His issues are predominantly citrus, a little bit of berry here, but almonds, wheat grains, corn, sesame, a bunch of other grain issues here. Now, the alkaline diet says don't eat dairy and meat proteins and eat lots of almonds and grains and these sorts of things. And if you look at his test, it's the exact opposite of what he should have been doing, with the exception of some of the fruits. So he didn't see any impact with the alkaline diet. One more point to make about this alkaline diet program. Our body has an incredible system of checks and balances for buffering acid in the bloodstream. So many of our body functions, the brain, the heart, a lot of our critical organ systems, these types of parameters have to be regulated in a very narrow therapeutic range, calcium and magnesium and pH and these sorts of things. So when we eat acidic foods and we eat alkaline foods, our body can actually correct for that to make sure our pH in the body is very regulated. But some of these diet programs are based on the concept that if we eat an acid food, we're going to become acidic. If we eat an alkaline food, we'll become alkaline. But our body systems don't work that way. Another way to explain this is a lot of people with reflux, indigestion, and heartburn, which is an inflammation of the stomach lining, they will notice improvements if they take apple cider vinegar. Well, you're eating or taking in supplement form a supplement or a food, which is acidic by nature, and they're seeing an improvement in an inflammatory symptom. Almonds are one of the highest alkalinizing foods based off all these programs. But I showed you, and I'm going to show you more, several examples of where almond was a primary inflammatory food for people. Here's another patient. We'll talk about the paleo diet with this patient. This was a 46-year-old female with chronic fatigue and fibromyalgia and some digestive issues. The paleo diet is sort of the hunter-gatherer diet. It's a diet high in animal proteins, poultry, beef, eggs, etc. Low in dairy, except for heavy fermented creams and clarified butter. Reduced nuts and fruits, reduced grains and legumes. Now, when this lady would go and do that paleo diet, look at her dairy products right here. Off the charts, especially casein and whey, the two dairy proteins. Her IgG reactions to egg was very high. Banana, cranberry, and pineapple were very high, and almond was extremely high here. So this paleo diet, which says eat a diet high in animal proteins, including eggs, you can see why that wouldn't fit her immunological or food reactivity profile very well. Now let's flip this around a little bit. If we took that 59-year-old with the psoriasis and we gave him the paleo diet, which says eat eggs and eat meat proteins and these sorts of things, that would actually fit him fairly well. He doesn't have dairy issues. He doesn't have beef and egg issues. And this diet reduces nuts and fruits and grains and beans, which is this profile right here, which is right off the charts for him. So if he had happened across the paleo diet, he probably would have felt better. So when we pick an anti-inflammatory diet off the internet or by a program or a book, it's a little bit like we're buying a lottery ticket and hoping that it fits our immune system profile. Now, sometimes we buy those books and programs and they actually do fit our profiles and we feel really well. But I'm talking about the cases where these diet programs don't work for people. It's they bought a lottery ticket and they didn't win. Here are two test results side by side for two women with fibromyalgia. One had IBS, the other had arthritis and some mood and anxiety disorders. The 66-year-old female, you can see she had a big dairy issue, banana, cranberry, pineapple, egg, baker's and brewer's yeast, crab, and almond. The second lady with fibromyalgia, she had no dairy issues, no egg issues, no yeast, well, a little bit of a yeast issue, but she had an almond issue as well, and she had banana and pineapple. So the first one was dairy, banana, cranberry, pineapple, and egg. The second lady was banana, pineapple, and wheat grains. Outside of a couple of fruits, those food profiles are totally different, but yet they had the exact same inflammatory condition. The other interesting thing here is the almonds showed up on both. Almond tends to show up in a lot of people with inflammatory muscle and joint issues. And if we think of the alkaline diet, almond is one of the star foods on that diet program because it's supposed to be so alkalizing. So these reports are examples of both patients had compound food profiles, almond, dairy, wheat, etc., where they had to combine these at the same time in order to see improvements. If they had just focused on gluten, one may have felt a little bit better, the other wouldn't have seen any improvements because they weren't allergic to gluten. So you can see the importance of lining these reactive foods all up together at the same time when we implement a diet program. Here's two more tests with two IBS patients. We talked about this in my IBS video. One was 39-year-old, had IBS diarrhea, eczema, cystitis, and yeast issues. The other was a 57-year-old female with IBS diarrhea, joint pain, chronic fatigue, and anxiety issues. Both had inflammatory issues, and their other problems were slightly different, but inflammation was at the core of most of those problems. The first patient here had an egg issue. The second patient had an egg issue, but also a dairy issue, and the first person didn't have a dairy issue. We go down the list here. The first patient had egg, but also chicken and turkey. It was essentially a poultry issue. The second patient had no beef issues or chicken issues at all. The first patient had a yeast issue. The second patient had a caffeine issue. We get down to the fruits. The first patient had banana, blueberry, and pineapple. The second patient had blueberry, cranberry, and lemon. Different fruit profiles. The first patient had some of the brassicas, broccoli, cabbage, cauliflower, kale, and mushroom. The second patient had no vegetable issues. Now, based off generic diet ideals, the brassicas, cabbage, cauliflower, and broccoli, kale, and mushroom are supposed to be superfoods, super healthy for us, not if we're allergic or reactive to them. We keep going down the list. The first patient had gluten and oat issues. The second patient had oat issues. Now, the whole world tends to be a little bit hyper-focused on gluten issues in people today. You can see here the gluten and oat patient would have responded at least partially to a gluten-free diet, but the second patient wouldn't. Now, most people assume gluten is causing their issues, and they assume because oats are gluten-free that they are okay on a gluten-free diet. Well, the second patient here, she could go on a gluten-free diet and eat oats, and she would probably feel worse. If we go down the list, almond again in both of these patients. The second patient had chia and sesame over here. Both patients had cinnamon issues. One had pepper and ginger issues. So two completely different food profiles with major groups differing amongst the two of them. One had dairy and egg, the other only had egg. One had gluten and oats, the other had oats and not gluten. One had some super healthy vegetables and the other didn't as reactive inflammatory foods. So these inflammatory food profiles are essentially coded by our genes and DNA. The receptors in these patients were designed to bind to these foods. And because our genes and DNA are all different, you can see where our food profiles are all going to be different. This test result is my profile, my IgG profile. I've tested for IgA as well with a different lab. We're just going to go over my IgGs right now. When we look at my list here, you can see dairy is okay. Eggs are okay. I get into some whitefish issues, cod, haddock, halibut, scallop, baker's yeast, blueberry, kelp and mushroom, gluten, rice, pea, sesame, walnut, pepper, cinnamon, and ginger. I want to focus on the gluten and rice component here. Now, when people try a gluten-free diet, they go to gluten-free foods. And a lot of those gluten-free dieters will end up eating oats or steel-cut oats or gluten-free oats because they are gluten-free. But you can now see that you can just as easily have a reaction to oats as you can to gluten. In fact, I see oats show up on more tests than gluten does, actually. The other issue with a gluten-free diet is when you go gluten-free and you buy gluten-free flour products, gluten-free breads, gluten-free cookies, and things like this, the most common alternative flour that's in almost every one of those gluten-free foods is rice flour. Now, with my example here, rice actually bothers me more than gluten does. I can tolerate little bits of gluten. I don't react as badly. When I eat rice, I get very, very ill. It affects my digestive tract. It affects my psoriasis, like I mentioned earlier. So if I don't have this profile figured out, if I go gluten-free and eat rice products, I'm going to feel very unwell. In fact, I do feel unwell. Another issue here with gluten, and I touched on this briefly before. There are two proteins in wheat that we tend to react to. One is gliadin. The other is gluten. Now, the celiac testing, the transglutaminase testing, is for an IgA antibody to gliadin. It's typically not done for gluten. And when gluten shows up on testing, gliadin hardly ever shows up. So the point here is people can have a celiac test done for IgA antibodies to gliadin, and it can come back negative, and they can be told they don't have a gluten issue. But these people often weren't tested for gluten. You can have a gluten issue and not a gliadin issue. This would present with someone who says, when I eat gluten, I feel sick, I feel inflamed, I don't feel well, but my celiac test came back negative. It's because they didn't actually test for the right protein found in the wheat product. I have actually had celiac testing done years and years ago, and it came back negative. But on this test, gluten showed up. Here's another example showing what I'm talking about. You can see the IgA antibody to gliadin is very low here, and the G antibody to gliadin is low. But the IgG antibody to gluten, which is a different wheat protein, is very high. Again, this person would test negative for celiac, but if they ate a gluten-free diet, they would probably feel better. Another point to make with my test is to talk about pepper, cinnamon, and ginger. Now, through COVID, I went through the throes of andropause. My psoriasis erupted and got worse. My digestive issues got a little bit worse. And I was actually following my normal diet that would normally manage those. So being a naturopath, I went to do leaky gut support, a few supplements and things like this. I tightened my diet up even more, and I wasn't feeling better. Now, what was happening is some of the leaky gut supplements, a lot of them contained turmeric. Turmeric is supposed to be a digestive aid. It's supposed to be anti-inflammatory. Now, most of those supplements I was taking had turmeric in them. And when I started taking them, I wasn't feeling well, so I kept taking more and more and more. This went on for close to a year. Finally, I went to a different company that actually checked for ginger. They don't check for turmeric. And I saw ginger was high here, and ginger and turmeric are in the same family. Now, literally within about a week of giving up the turmeric supplements in my leaky gut supplement repair program, I started to feel better. And to this day, if I take turmeric in food or if I take turmeric in a supplement form, I don't feel well. I've had several patients have this reaction as well. So just because the internet or a textbook or a program says this food is anti-inflammatory for this purpose, or this food is anti-inflammatory for another purpose, it doesn't mean it's going to fit our immune system profile. Now, once again, some people will buy or try these types of programs and they will definitely see benefits from them. But what's happening there is that the program they're trying or they've bought happens to fit their immune system profile better than some of these other programs do. So I'm not going to suggest those of you out there who have tried these programs and benefited from them, those programs didn't serve a purpose for you. They absolutely did. But when someone goes out and tries a program or tries several programs and they don't see a benefit, it doesn't mean that diet can't affect their inflammation issues. It just means they didn't get the right diet profile. That's the key to figuring all this stuff out.